Hi, welcome to the second part of very short answers questions. Now we will see in quantum physics and solids. So the first question will be, what is a black body radiation? So first we have to know what is black body. So black body is a object which can absorb all the electromagnetic radiation incident on it, irrespective of its frequency or angle. Or whenever it is emitting, it will emit everything, whatever it absorbs. That is what we call black body. And the radiation emitted by the black body is known as black body radiation. A black body radiation diagram, whatever experimentally observed and theoretically Rayleigh and Wiens try to fit based on a classical mechanics but not able to do so. Then Planck introduced Planck's law and then he is able to explain. That's what next one is define Heisenberg uncertainty principle. So Heisenberg uncertainty principle states that it is impossible to measure both position and momentum of a particle simultaneously to any desired degree of accuracy. Whenever we are measuring position and momentum, on the same line we have energy and time. So uncertainties will exist as a default. Next one is, what is the difference between matter waves and electromagnetic waves? Matter wave is associated with a moving particle or material particle, whereas electromagnetic waves are nothing but oscillating charged particles give rise to electromagnetic waves. And wavelength of the matter wave is given by lambda is equal to h by mv. This is de Broglie wavelength equation. Then wavelength of electromagnetic wave is given by lambda is equal to hc by e. Wavelength of matter waves depends upon the mass of the particle and velocity. Here wavelength of electromagnetic wave depends upon the energy of the photon. It can travel with a velocity greater than the velocity of light in vacuum. It can travel with a velocity equal to the speed of the light in vacuum, c equal to 3 into 10 power 8 meter per second. This one matter wave is not electromagnetic wave, and in this electromagnetic wave we have electric and magnetic fields. Then define wave function and write its physical significance. By using wave function we can extract all the information related to the system. Wave function is a mathematical function describe the behavior of quantum system. So it will describe the behavior of quantum system. It provides the information about probability of finding the particle in particular position or with particular momentum. The physical significance of wave function is that it allows us to calculate the probabilities of different outcomes in quantum mechanical experiments. Next one, what is the de Broglie hypothesis of matter waves? Matter waves also have dual nature, means they will act as a wave as well as a particle. And the relation for this one is lambda is equal to h by p, where h is a Planck's constant, p is a momentum of matter wave, v is the velocity of the particle. Then what is the dual nature of the light? Light has a dual nature. One is a wave nature, another one is a particle nature. Wave nature will be proved in case of interference, diffraction and polarization, whereas particle nature of the light is proved in photoelectric effect, Compton effect, pair production. So combinedly we can say that light has a dual nature. Based on this only de Broglie proposed matter also has a dual nature. Then what is a Bloch theorem? So Bloch theorem simply says that whenever electron is moving in a crystal, that wave function can be written as the product of periodic function and plane wave function. Periodic function, this is a plane wave function. Then what is the effective mass? So whenever electron is moving inside the periodic potentials, its mass will change due to the field present there, whether it may be electric field or magnetic field. Then the mass is known as effective mass and calculated by this formula. All the best, and signing off, Dr. Sivanagi Reddy. Jai Hind.